Good morning to all of you. Can you see the slide?
Yes.
Okay, so within 2 minutes we will start as students are still learning. So I'm changing the slide. Those who are online, can you get these points? I'm changing the slide. First slide, then second, third.
Yes, sir. Yes, sir.
Okay. Is it visible?
Yes, sir.
Okay. So today what we are doing, we are going for some introductory points related to this 8th chapter. And afterwards, I will give some task to you as we are on the verge of completion of our syllabus. We will discuss the points what we have covered earlier. Otherwise, what happens? Whatever we are covering, that you can remember, you can tell the answer abruptly. But if I ask the question, what we have prepared or completed earlier, then it may be difficult. Like, what is meant by Hall coefficient and its definition? Anybody want to share? Online definition of Hall coefficient is? Okay, so abruptly I'm asking. Maybe you are thinking that long ago we have discussed these things. Okay, so no problem for that. I will give time for the preparation and you can recall, remember, and you can go for that. So 15 to 20 minutes we will utilize for this chapter, and simultaneously we will discuss some of the points. Syllabus we have discussed first, what we have covered, how to justify each and everything regarding online and offline. In case of online exam, you know that MCQs are there. So you have to deal with the MCQs, but if offline is there, then the scenario gets changed. So let us try to prepare for any type of exam that you have to face in the future. So chapter number 8, Introduction to Quantum Mechanics and Nanotechnology. So here two terms are there. First is Introduction to Quantum Mechanics and second is Nanotechnology. In Introduction to Quantum Mechanics, we are starting with the de Broglie hypothesis. Then de Broglie wavelength of matter waves, that is lambda is equal to h divided by p. Then de Broglie wavelength expressed in terms of kinetic energy and de Broglie wavelength associated with particle in thermal equilibrium and properties of matter waves. So these terms we will cover today. Then Davison-Germer experiment, I think it was there in the 12th. Is it correct? Davison-Germer experiment. So it is a simple one. When we discuss, you can understand easily. So these are the points related to first part, Introduction to Quantum Mechanics. It is an introductory part only. Then nanotechnology comes. So in case of nanotechnology, first introduction, what is meant by nanotechnology? We have heard about this. In our syllabus, we are concentrating on the carbon nanotubes, that is carbon material, where they are differentiated according to the how many walls they have, that is single wall, multi-wall. You can see here. So it is simple one. Then further we are classifying according to orientation of this carbon structure, and some of the mathematical terms or numerical factors are there, depends upon their symmetries and vectors. And last one is applications of nanotechnology. So this is the chapter. It requires 1 or 2 lectures. So today we will cover the introductory part, and remaining half, that's last 20-25 minutes, we utilize for discussion. Means from today onwards we are completing our remaining chapter, plus we are starting the revision of our syllabus, you can see. So listen carefully. Introduction to Quantum Mechanics and Nanotechnology. In this, we are dealing with now first one, Introduction to Quantum Mechanics. So quantum mechanics, maybe you have heard the things. So quantum mechanics is the sub branch of physics. Whatever you have or we have discussed, it is related to classical mechanics or Newtonian mechanics. So the start of quantum mechanics is from this de Broglie hypothesis, de Broglie wavelength, Schrodinger's wave equation, and the need of or necessity of equations regarding some of the terms, like when we are considering in classical mechanics, particle is moving with certain velocity, then we are considering its a position and its a motion. Okay, but when we consider its a position, that particle is in motion, and when we try to detect its motion, then how we can check its position. So that is the basic start or basic question which evolves this quantum mechanics term. So some equations put, and from that we are started discussing about the limitations of classical mechanics, just like relativistic mechanics we have discovered, and from that these hypothesis and Schrodinger wave equation developed. So in our case, we have just an introductory term related to matter waves or de Broglie wavelength. So what is that exactly? We will check. So in 1924, Louis de Broglie extended the wave particle dualism of light to the material particles. He responded out that nature exhibits a great amount of symmetry. Therefore, if a light wave can act as a wave sometimes and as a particle at other times, that is the dual nature of light, then particles such as electrons should also act as a wave at times. This is known as de Broglie hypothesis. हे hypothesis थोडक्यात काय सांगते की वेव्ह नेचर आणि पार्टिकल नेचर आपण ड्युअलिटी सांगतो लाईटची, तर तसंच इलेक्ट्रॉन्स जे आहेत, जे ऍक्च्युअली पार्टिकल आहेत, तर ते सुद्धा काय करतात, ऍक्ट ऍज ए वेव्ह. मीन्स त्यांचं जे नेचर आहे किंवा त्यांच्याशी रिलेटेड जर आपण काही एक्सपेरिमेंट करून बघितले, Davison-Germer experiment आहे तो तेच प्रूव्ह करतो. Davison-Germer experiment proves the wave nature of electrons or matter. that wave is called as matter wave. So that hypothesis is on the basis that these particles are also acts as a wave. Nothing else. This is the hypothesis. So according to de Broglie hypothesis, any moving particle is associated with a wave. The waves associated with particles are known as de Broglie waves or matter waves. म्हणजे काय की पार्टिकल एक आहे त्याची मोशन आपण जेव्हा कन्सिडर करतो तर त्याच्याऐवजी आपण हे कन्सिडर करतो की हा जो पार्टिकल आहे तो वेव्ह नेचर मध्ये मूव्ह होतो. म्हणजे आपल्याला वेव्ह स्ट्रक्चर मध्ये याची मोशन बघायला मिळते. So here we are just considering this hypothesis and putting the facts. So the wavelength lambda of matter waves associated with a particle moving with velocity v is inversely proportional to the magnitude of the moment of the particle. Thus, we are writing this as lambda is equal to h divided by mv. So we are getting these terms that we have discussed, I think, in our syllabus points also. We have discussed all these terms in our syllabus discussion here. So lambda is equal to h divided by mv, and this Derivation German experiment, or p is equal to mv we are writing. So how we can get that? So two terms are there. First thing is equation, that is E is equal to h nu, that you know, that is nothing but the energy packets or bundles called as photons. And what is the relativity last equation? E is equal to mc square, that also we have discussed. So here this h nu is nothing but frequency. So frequency is nothing but, how we can write this as hc by lambda. Is it correct? And this as mc square, we are comparing with this as LHS is same. So c cancels each other. What remains? H divided by lambda is equal to mc is remaining. So instead of c, we are just using symbol v as it is velocity. So it is mv, and we want value of lambda. So I can write here lambda is equal to h by mv, and this mv is nothing but p also. Okay, so we can write this as h by p also. These terms are clear? So you write it somewhere, everyone, those who are online, those who also have notebook, of course. So everyone write these things. हे कसं होतं आता लक्षात येते, सोपं आहे. पण लॅम्बडा इज इक्वल टू h by p हे कसं काय आलं, किंवा p इज इक्वल टू mv आणि आपण हे लिहितोय. तर त्याच्यासाठी दोन इक्वेशन कन्सिडर करायचे. राइट, फर्स्ट वन E is equal to h nu. Right, first one E is equal to h nu. Next line, right, number 2, E is equal to mc square. E is equal to h nu. E is equal to mc square. Two equations. So next line, write down. Comparing equation 1 and 2, we get. Comparing equation 1 and 2, we get. So next line, write down this step, what I am writing here below. H nu is equal to mc square. आपण directly लिहूया पहिल्यांदा, नंतर nu ची व्हॅल्यू आपण चेंज करूया. This step you have to write h nu is equal to mc square. Next line, as nu is equal to c by lambda. As nu is equal to c by lambda. Therefore, next line, go for this one, that is hc by lambda is equal to mc square. Hc by lambda is equal to mc square. So C cancels each other. Next line, write down H by lambda is equal to mv. H by lambda is equal to mv. This step, H by lambda is equal to mv. And next line, lambda is equal to H by mv. Lambda is equal to H by mv, or lambda is equal to simply H by p. All these are your possible MCQs also. That is lambda is equal to H by mv, or lambda is equal to H by p, or p is equal to mv. These three terms. Okay. So this is explanation that how we get lambda is equal to H by p. याच्यासाठी आपण हे डिस्कस करत होतो. So this is the first point, which is important one. Once you know this value, the next two we are directly calculating or writing. So here we have written this value, that is the wavelength lambda of matter waves associated with a particle moving with velocity v is inversely proportional to the magnitude of momentum of the particle, that is mv. Thus, we are writing lambda is equal to H by mv. So is it clear to all? Shall we proceed?
Yes, sir.
Okay. So now next, we are just playing with the equations by considering some terms and writing the values, which are your once again MCQ values and 3 marks question. It is very simple. So you prepare this chapter. So de Broglie wavelength of matter waves. As a photon travels with velocity c, we can express its momentum as. So this is nothing but once again the same thing we have written, and we got this H by lambda, that is E is equal to H nu. H nu is nothing but this is C by lambda, etc. We have calculated, and lambda is equal to H by P we got. So it is a slightly confusing. That's why I have written that steps. De Broglie proposed that the relation between the momentum and the wavelength of a photon is a universal one and must be applicable to photons and material particles as well. So here we are comparing two things. One is wave nature of light, and another is wave nature of particle. And by comparing that, we are getting all the details. So photons and material particles as well means material particles which acts as a wave we are considering. So next is de Broglie wavelength expressed in terms of kinetic energy. So if a particle has a kinetic energy, then we know that kinetic energy is equal to 1/2 mv square. So here what we are doing, we are just adding m on numerator and denominator. So it becomes m square v square divided by twice m. mv is nothing but p, right? So it becomes p square by twice m here. So p is equal to, याच्यावरून आपण p काढले, p स्क्वेअर म्हणजे काय येणार, तर twice m into kinetic energy. p म्हणजे काय येणार, under root twice m into kinetic energy. And if we put the value of p here, what it becomes, lambda is equal to h divided by p. Instead of p, what we have written, under root twice m ke. Getting this? Okay, so it is simple one. Kinetic energy काय, 1/2 mv square. m न मल्टिप्लाय केलं दोन्ही साइडला, mv म्हणजे p असतं, तर m square v square काय येणार, p square. p square आपण twice m म्हणजे काय, kinetic energy. तर p square ची व्हॅल्यू आपण काढली, हे twice m शिफ्ट होणार इकडे. सो p square is nothing but twice m into ke, आणि p म्हणजे काय, under root twice m into k. So we are putting the value of p in this equation. What we can get, lambda is equal to h divided by twice m ke. So this is another value. So you can write next line, de Broglie wavelength expressed in terms of kinetic energy is lambda is equal to h divided by under root twice mk. तर हे अजून एक व्हॅल्यू आहे, लक्षात ठेवा for possible MCQ. Then we can add one more value. So de Broglie wavelength associated with particle in thermal equilibrium. So if particles are in thermal equilibrium at temperature capital T, then their kinetic energy is given by kinetic energy is equal to 3/2 kT. So this you have studied in 11th and 12th. Okay, and how it comes? So I have missed to add the slide. So I will next lecture I will give the solution for this step. Okay, that is kinetic energy is equal to 3/2 kT. And if we consider that kinetic energy as 3/2 kT in this equation, so what happens? These two cancels each other, and what remains? Thrice m kT. So lambda is equal to h divided by under root thrice m kT we are getting. So this is another value, that is de Broglie wavelength associated with particle in thermal equilibrium. So just we are getting the terms here by considering the de Broglie wavelength. Okay, so we have got these terms or got these values. So I hope that it is clear to you. Any doubt regarding steps? Shall we proceed? Now, next thing is properties of matter waves. So when we are considering this matter motion in terms of matter waves, there are certain properties, just like properties of ultrasonic waves we have discussed. So matter waves are produced by the motion of the particles that we are discussing and are independent of the charge. Therefore, they are neither electromagnetic nor acoustic waves, but are a new kind of waves. That is nothing but matter waves we are saying. They can travel through vacuum and do not require any material medium for their propagation. The smaller the velocity of the particle, the longer is the wavelength of the matter wave associated with it. The lighter the particle, the longer is the wavelength of matter wave associated with it. Next, the velocity of matter waves depends on the velocity of material particle and is not a constant quantity. That is, the velocity of matter waves is not the constant one. It is dependent upon the velocity of material particle. They exhibit diffraction phenomenon as any other waves. आता ह्या सगळ्या प्रॉपर्टीज आहेत त्या कशासाठी सांगितल्यात, तर जसं वेव्ह नेचर आहे लाईटचं, तर तसंच ते मॅटरचं सुद्धा जे वेव्ह नेचर आहे, तर ते सांगण्यासाठी आपण या प्रॉपर्टीज सांगतोय, की ज्यामध्ये पहिल्या याच्यामध्ये आपण काय म्हणतोय, मॅटर वेव्हज आर प्रोड्युस्ड बाय, मॅटर वेव्हज कशा प्रोड्यूस होतात, तर मोशन ऑफ पार्टिकल्स. आता सांगितलं की आपण मुव्हिंग पार्टिकल जो कन्सिडर करतो त्याच्याऐवजी फक्त आपण त्याला या स्टाईल मध्ये कन्सिडर करतो. Okay, so when motion of particles we are considering, then only matter waves we are considering, and are independent of the charge. It is not dependent on the charge. So electromagnetic acoustics wave च्या प्रकारचे नसतात, तर हा वेगळाच प्रकार आहे असं आपण म्हणतो, ज्याला आपण मॅटर वेव्ह म्हणतो. Then they can travel in vacuum and do not require any material medium for their propagation. Now here few points we have to consider, that when we are considering the matter waves, so it is not mean that we are considering a big particles and they are moving in the vacuum, etc. So at the level of electrons we are considering. Okay, so we just complete it and then we discuss the things related to Higgs boson or God particle. The smaller the velocity of the particle, the longer is the wavelength. जेवढी velocity तिची small असेल तिची wavelength longer असेल. Lighter जेवढा particle असेल तिची wavelength longer असेल. त्यानंतर velocity जी आहे मॅटर वेव्हची, तर ती सेम नसते, कॉन्स्टंट क्वांटिटी नसते. ती कशावर डिपेंडंट आहे, तर त्या मॅटर पार्टिकलच्या और मटेरियल पार्टिकलच्या वेलोसिटीवर डिपेंडंट आहे. आणि ऑफकोर्स आपण त्याला जर मॅटर वेव्ह म्हणतोय, वेव्ह जर म्हटलं तर ऑप्टिक्सचे जे नियम आहेत ते त्याला काय होतात, लागू होतात. मीन्स डिफ्रॅक्शन फेनोमेनन वी कॅन गेट जस्ट लाईक अदर वेव्स. ओके, नाउ कम बॅक टू द पॉइंट, that is Higgs boson or God particle. Maybe you have heard about that. That large hadron collider experiment was done a few years ago, and we can got this Higgs boson or God particle. So that gives us idea about how the energy gets converted into mass. this E to M process is there. So these bosons, Higgs bosons or God particles, are the key factors for conversion from energy to matter. Okay? Means there is a something process which converts energy to matter. Like if we consider the atom, so what are inside atom? You know that at the center, what is there? At the center of atom, as the nucleus, then electrons are revolving around the nucleus, means electrons are there. In case of nucleus, there are protons and neutrons. But is it true that only two terms are there? Anybody knows other things other than proton and neutron? Okay, so there is a series of particles which is called as elementary particles. If you Google search elementary particles, then you can get all the details like pions, muons, mesons, positrons, etc. And all these are nothing but constituents of these terms, which is called as elementary particles. If you Google search, you can get the details as a content beyond the syllabus or information more than that if we consider. Next, maybe you know about the quarks. Okay, so what are the quarks? So there are three types of quarks which are making these protons and neutrons. Means they are the raw material for these protons and neutrons. Okay, and next to quarks there are Higgs bosons. आता जे तुम्हाला मी म्हटलं Higgs bosons किंवा God particle तुम्ही ऐकलं असेल तर ते जे particles आहेत तर ते सुद्धा quarksच्या आधीचे. Means you can imagine that initially we don't know about the atomic things, then nucleus, electrons, protons, neutrons, then quarks, and then now Higgs boson. Means you are maybe thinking that what is going on, sir? You are saying some complicated things, that something is there, below that something is there, below that something is there. So scientists are saying that nature is so complicated that if we open one door, then three next doors are waiting for us. Means if we solve one question, three more question comes. Like that, we are still searching the things related to the mystery of nature in terms of scientific language. So all these things we are discussing because we are discussing about quantum mechanics and matter waves. Okay, so this is additional information, or you can say content beyond the syllabus. So is it clear what we have discussed today? What is meant by de Broglie hypothesis and de Broglie wavelength? Those who are online, give me response.
Yes, sir.
Is it clear? Okay. So what we do now, we repeat this tomorrow also, and we go for Derivation experiment. Derivation experiment म्हणजे one line sentence जर सांगायचं म्हटलं तर हा Derivation जो experiment आहे तो कशासाठी आपण डिस्कस करतोय किंवा कशासाठी केला गेला, तर जसं आपलं इक्वेशन आहे कशाचं, Bragg's lawचं. Okay, what is the equation of Bragg's law? 2d sin theta is equal to n lambda. So 2d sin theta is equal to n lambda. That equation we are using for the X-ray beam, that is wave nature. Similarly here, Derivation experiment we are using by bombarding this diffracted electron beam, and by taking some graphs, we are proving that these electrons is also showing the wave nature or like matter wave. So Derivation experiment proves the wave nature of particle. Okay, that is the significance of Derivation experiment. So that part we will discuss in our next one, and this nanotechnology etc. we cover. So now we come to our syllabus points. So we have 10 to 15 minutes. Let us discuss these things. So can anybody tell me only syllabus points of first chapter? online, I will give preference to you first. Syllabus points. First chapter ची कुठले? पहिला point कुठला discuss केला आपण?
Solids.
Yes. Online, I am asking. Anybody want to share the syllabus points for first chapter?
Classification of solids.
Next.
Fermi level.
Fermi level.
Yes. Next.
Fermi direct distribution.
Fermi direct distribution function. Next.
Hall effect. Level in
Hall effect.
interesting.
Hall effect derivation. Then next.
Application of Hall effect.
Application of Hall effect. Next.
Effect of impurity concentration on
Effect of
Fermi.
impurity concentration on Fermi level for N-type, P-type. Then derivation of Fermi level in intrinsic semiconductor.
And extrinsic.
Yes. So these are the points that we have covered. So here are these points. Classification of solids, Fermi level, Fermi direct probability distribution function, Fermi level in intrinsic and extrinsic semiconductors, effect of impurity concentration on Fermi level, derivation for Fermi level, then Hall effect and applications of Hall effect. So can anybody want to share the definition of Hall effect? Those who are online. Definition of Hall effect. Unmute yourself and just tell the definition of Hall effect.
Hello, sir.
Anybody? Please
If
continue.
a piece of metal or semiconductor carrying the current I is placed in transverse magnetic field at a potential difference is produced in a direction of normal to the both current and magnetic field. This phenomenon is known as Hall effect.
The next thing is, what is the derivation value for the Fermi level in intrinsic semiconductor? Fermi level in intrinsic semiconductor से derivation है तिची last value काय येते? What is the last value? Yes. Online, those who are online, anybody want to share?
EF is equal to EC divided by 2.
EF is equal to
EG by 2.
EG by 2.
divided by 2.
yes, EF is equal to EG by 2 or EF is equal to EC plus EV by 2. Then what is the equation for Fermi direct probability distribution function? F of E is equal to
1 plus E.
1 divided by 1 plus E raised to E minus EF divided by KT. Is it correct?
Yes, sir.
Okay. Now, next thing is you have to explain in short the terms I am asking. First is insulator. So I am giving chance to online student about insulator. And next two, I want to heard from those who are offline. That is semiconductor and conductor. So about insulator, can anybody want to share what is meant by insulator? It's points. Insulator मध्ये आपण काय काय मेंशन करतो? Unmute yourself. What is meant by insulator?
Orbit and energy band is wide.
Okay. Then next one. Energy band gap. What is the range of energy band gap?
5 to 10 electric volt.
Yes, 5 to 10 electron volt. Then next,
Electron cannot jump from valence band
to conduction band. Yes. If we connect that in electric field, then also we are not getting response as energy band gap is more. And at extreme conditions, insulator acts as poor conductors. Okay. And we can write example as glass, wood, plastic, etc. Okay. Now come to the second one, that is semiconductors. So I request those who are offline, anyone can discuss and tell about the semiconductor. You can raise your hand and you can tell. Anybody?
Semiconductor material orbital band gap is very small. It varies from 0.2 to 0.5 electron volt.
Then next point.
Electron jump from valence band to conduction band.
Yes, and what are the charge carriers in case of semiconductors? Only electrons. Electrons and holes are the charge carriers. And example with their energy band gap. For silicon, it is, what is the value for silicon? 1.1 electron volt. For germanium, it is
0.7.
0.7 electron volt. Okay. Then next, third one, conductor from boys side. Anyone? Offline? Yes. So electrons can easily move from valence band to conduction band. There is no structure to establish the holes, as there is a overlapping of valence band and conduction band, and number of electrons decide the conductivity of the material. Examples, you can write gold, silver, copper. Yes, you can use any example, no problem. So classification of solids. आता हे परत एकदा रिपीट करतो. क्लासिफिकेशन ऑफ सॉलिड्स असा जर प्रश्न आला तर अमॉर्फस आणि क्रिस्टलाइन लिहायचं नाही. काय लिहायचं आपल्याला जे दिले ते लिहायचे. तुम्हाला असाइनमेंट क्वेश्चन्स मध्ये चॅप्टर 1 मध्ये क्लासिफिकेशन सॉलिड्सचा क्वेश्चन होता का चॅप्टर 2 मध्ये? ठीक आहे, मग तुम्ही चॅप्टर 1 मधला जो आहे की क्लासिफाय इनटू इन्सुलेटर, सेमीकंडक्टर अँड कंडक्टर, तर चॅप्टर 1 मधला क्वेश्चन आहे आणि आन्सर लिहिले चॅप्टर 2 चं. सो इट इज अ ग्रेट डिस्कवरी. सो डोंट डू दॅट थिंग्स unnecessarily. You are losing your marks. Then next, Fermi Dirac we have discussed. Okay, now those who are online, anybody want to share the effect of impurity concentration of Fermi level in case of N type? Just give me few lines that what happens when we are increasing the impurity from low level, medium level, high level. Anybody? Unmute yourself. Girls, boys, anyone? Those who are online. Effect of impurity concentration on Fermi level in N type. What happens?
Fermi level gets shifted towards conduction band.
Okay. Then another points. Effect of impurity concentration on Fermi level in case of N type.
Donor level overlap the conduction band.
Okay, donor level overlap the conduction band. Then what about energy band gap?
Energy band gap goes decrease.
Yes, energy band gap decreases. So initially, the impurity concentration is less, so interaction is not there regarding the impurity atoms. As impurity concentration increases, interaction starts, and instead of single energy level, they are forming their band. So at low level, we are getting the conduction, that donor level near conduction band. So next to medium level, as impurity concentration increases, instead of a single level, there is a formation of energy band and Fermi level shift towards the conduction band. In case of high level doping, the bandwidth or that band broadens and Fermi level shift inside the conduction band. In opposite, the energy band gap decreases. So as impurity concentration increases, Fermi level moves closer and closer to conduction band in case of N-type semiconductor. Okay, so similarly, you can consider this and write for P-type semiconductor. Then next is Hall effect. So for Hall effect, we have to consider the definition, then figure what is meant by current density, equilibrium condition, F is equal to FL, that is Lorentz force due to magnetic field, and Hall field due to the electric field generation. They are balancing each other, F is equal to FL, that is Hall field EH. Then we are adding some terms, editing some terms, and F is equal to FL, we are writing the equations. Then solving the terms, we can get VH, value of VH. Then we are modifying that value. Then we are defining Hall coefficient. So what is the definition of Hall coefficient? Hall field per unit current density per unit magnetic field induction. And we can get the value of Hall coefficient, that is RH is equal to 1 upon PE. That value we can get. Then putting that value of RH, we can get value of VH in terms of RH, then RH in terms of VH. Last, applications of Hall effect to determine the type of semiconductor, charge carrier concentration, then mobility of charge carriers, that is mu is equal to sigma into RH. And last one is that flux density meter we can use. So next lecture, now I am giving you one task. Those who are online and offline, next lecture is tomorrow. You have to prepare this Hall effect derivation. Okay. So Hall effect derivation you have to prepare means I will give 10 to 15 minutes during the lecture for preparation, and after that you have to try to write that how many steps you can write, how you can write, and accordingly we will prepare this 5 marks question. Okay, so we have to cover our chapter also. So first half we give for the chapter, and next half we will discuss about these things. Okay, so today we conclude here. Just check absent numbers. Roll number 1 present. Roll number 4 7 8. Next 12. Roll number 12. Roll number 20. 21. 22. Then 26. 27. 28. Okay. Then next 34. Roll number 34. 38. 39. 40. 41. 41. 42. 43. 45. 46. 47. Then 49. 50. 53. 38 is present. Okay. So roll number 12, 21, 27. Then 34, 40. Which number? 40. 41, 42. 42, 45. And 47. Okay, so we conclude here. Thank you.